All right, guys, so what we're covering today is chapter 1.3, solving simple equations. And most of these are also called one-step equations, where we only really are doing one step to be able to solve for the missing variable, or solve for the variable, to get the variable by itself. Now, the first two properties we're going to look at is addition property of equality and subtraction property of equality. Now, the addition property of equality right here says, or is pretty much adding the same number to each side of an equation produces an equivalent equation. So if A is equal to B, then A plus C is equal to B plus C. We can add the same things at both sides, and it doesn't change anything. It doesn't add anything. One side's not greater than the other. They're both equal. We can do the same thing with subtraction. So if A is equal to B, then A minus C is going to be the same as B minus C. We're keeping both sides of this equation, the same. We're either adding the same thing or we're subtracting the same thing from both sides, and it doesn't change anything. So that's our addition property of equality and our subtraction property of equality. And we're going to use those to be able to solve these here. So the first thing we're going to solve is this here. X minus 3 is equal to negative 5. So what we want to do is we want to get x by itself. So how will we do that? Well, the main way we will do that is by, well, I'm going to rewrite it here. So to get x by itself on this side here, to get x right over here by itself, what we're going to do is we're going to add 3 to both sides. So we're going to have x minus 3 plus 3. Negative 5 plus 3. We're going to add 3 to both sides. And this is how it would look using that property of our addition property of equality. Using that property is how it could look. Now, what we're going to do, and the way I'm going to do is I'm going to just write plus 3 underneath both of these here. It's negative 3 plus 3, or minus 3 plus 3 here. These cancel out because negative 3 plus 3 is 0. So we get x is equal to, well, negative 5 plus 3 is negative 2. So the value of x is negative 2 in this equation here. Now justify each step. Well, we just used our addition property of equality and added 3 to both sides. That's all we did. And that's how we solved this one here. That's all we had to do for this one. So let's look at another one here. So looking at this here, we want to get y by itself to be able to solve it. So in order to get y by itself, what we're going to do is we're going to add or subtract something here, because that's what we're using. We're mainly focusing on addition. We're mainly focusing on addition to subtraction right now. So we see y plus 2.8. So to get y by itself, so we're going to use our subtraction property of equality and subtract 2.8 from both sides. And I can do this because of my subtraction property of equality. So over here we'll have y. Well, 2.8 minus 2.8, these cancel. Now we have 0.9 minus 2.8. And again, if you have trouble doing this in your head, writing it out, or you can just use a calculator. You can do 0.9 minus 2.8 in a calculator. And you're going to get negative 1.9 as the value of y. You'll get negative 1.9 as the value of y. And that's it. So justifying our steps, well, we use the subtraction property of equality, and we subtracted 2.8 from both sides. And that's all we did there. Now I notice I missed this on the first one. They wanted us to check it. Well, the way we check it is we take our original equation equals negative 1.9 plus 2.8. And we plug our value back in for y. We just plug it back in. So when we plug it back in, so this is 0.9. Well, negative 1.9 plus 2.8 is 0.9. And since they both equal the same thing, it works. We checked it. And that's it. Okay, so we're doing the same thing again. We're trying to solve for the variable. We're trying to get the letter by itself, this variable m by itself. And to do that, what we're going to do is we're going to move this 4.8. We're going to get rid of it. And the way we can get rid of a positive 4.8 is by subtracting 4.8 from both sides using our subtraction property of equality. And when we subtract 4.8 from both sides, well, 4.8 minus 4.8 cancel each other out. They become 0. And we get m is equal to, so 9.2 minus 4.8. So you can do this in a calculator, or we can do it by hand. Because we can't do 2 minus 8, so we bring 1 over and we get 0.4. 8 minus 4 is 4. So the value of m is 4.4. So justify our steps. Well, what did we use? We used the subtraction property of equality, and we subtracted what? 4.8 from both sides. And that's all we did. So here are 3 more I want you to try. So you can pause the video at this point and give these a try on your own. Write these out and see if our answers match up. And I'm going to go on and work each one of these through. So our first one here, n plus 3 equals negative 7. So what we're going to do to get n by itself is use the subtraction property of equality, and we're going to subtract 3 from both sides. Because when I subtract 3 from both sides, well, 3 minus 3 here cancels out, leaving me n by itself, which we want, because if I have n by itself, I can find what its value is. Well, negative 7 minus 3 gives me negative 10, and that's our answer. That's all we have to do for this here. And we could check it. Well, our justified step is we use the subtraction property of equality, and we subtracted 3 from both sides. And checking it would show that it does work. So I'm not going to worry too much about checking it. Now the next one here looks like it's going to be different because we don't have anything we've done before. Because so far we've had whole numbers and decimals. Well, fractions aren't going to be any different. It seems like it might be, but they're not. So again, our main goal is to get g by itself. And what is with g? Our negative 1/3. So to get rid of the negative 1/3, what we're going to do is we're going to add 1/3 to both sides. When we add 1/3 to both sides, well, negative 1/3 plus 1/3, these two here become 0. They cancel each other out, leaving me with g by itself is equal to, so negative 2/3 plus 1/3. So again, you can do this by hand or you can do it in a calculator. But when we do negative 2/3 plus 1/3, we get negative 1/3. And that's our answer. So our justified step is that we use the addition property of equality and added 1/3 to both sides. And we could check it and it would show that this does work. And that brings us to our last one on here. So negative 6.5 is equal to p plus 3.9. Now to solve for the value of p, we need to get p by itself. And what is with p at the moment? 3.9. And it's positive. And since it's positive, we're going to subtract. We do the opposite. So we're going to subtract 3.9 from both sides. And using the reason we can do this is because of our subtraction property of equality. Well, 3.9 minus 3.9 will cancel each other out, leaving me with p by itself. Now we can subtract these here. So you can do this in a calculator. Do negative 6.5 minus 3.9. And they will combine to give us 10.4, negative 10.4. And that is our answer here. And again, our justified step is we use subtraction property of equality to get p by itself. And what we did to get p by itself was we subtracted 3.9 from both sides. And that's all we did to solve for this here. Now that brings us to our multiplication property of equality and division property of equality. Now they're very similar to our addition subtraction. We're doing the same thing to both sides, except we're using multiplication and division. So our multiplication property says if a is equal to b, well, and I multiply the same thing on both sides, it's still going to be equal. And the same thing's true for division. If a is equal to b and I divide the same thing on both sides, the equation will still be equal. We can multiply the same thing to both sides, or we can divide the same thing from both sides. We can do either one of these. So our first equation here, negative n over 5 is equal to negative 3. Now again, we're wanting to solve for the value of n. We want to get n by itself. So what we can do to get n by itself is that we can multiply both sides by negative 5. And that's what we're going to do here to get n by itself. Now I'm going to move this over a little bit so that I can write the negative 5 in here. So we're going to multiply both sides. Okay, so we're multiplying negative 5 on both sides. And the reason we do this is because we will get n by itself. Now when we multiply on this side over here, we multiply the negative 5 by n over negative 5. The negative 5 here that we're multiplying, this one right here, is going to multiply with the top. So we're going to have negative 5 times negative n over 5 is equal to. Now on this other side over here, well, negative 3 times negative 5. Well, a negative times a negative is a positive, and 3 times 5 is 15. Now over here, the 5 and 5 divided by 5 will simplify, and our negative times a negative will make us have a positive n. So n is equal to 15, and that's all we have to do to solve for this here. Now our justified step is we used our multiplication property of equality, and we multiplied both sides by negative 5. That's what we did to be able to solve this. And we can plug it back in and check and see that we will get the correct answer. So I'll go on and do it for this one here. We'll have negative 15 over 5. Well, 15 divided by 5 is 3, and because the negative sign, it is negative, so it works. And we get our answer. So let's look at the next one. So this one here, solve each equation, justify each step, check your answer. So pi times x is equal to negative 2 pi. Well, pi is an actual number. It's 3.1415926 and keeps going on. Pi is an actual number. So what that means for us is that we can actually divide by pi. We don't have to actually know that big, long, nasty decimal. So what we're going to do is we're going to divide both sides by pi to get x by itself. But when I divide both sides by pi using my property, the division property of equality, well, pi over pi simplifies to 1. So I have x by itself. Well, hey, look at this over here. This pi and this pi simplify out, leaving me with negative 2. So the value of x for this equation here is negative 2. And that's it. That's all we have to do for this here. So we used our division property of equality and divided both sides by pi, and we got our answer. And that's all we have to do for this problem here. Now let's look at our next one. 1.3z is equal to 5.2. Now we want to get the value of z by itself. So to get the value of z by itself, we're going to use our division property of equality and divide both sides by 1.3. We're dividing both sides by 1.3. And when I divide both sides by 1.3, these two here cancel out, leaving me with z is equal to 5.2 divided by 1.3. So when we divide these here, we can plug this into the calculator. You can grab a calculator. I'm going to go grab a calculator. So as I'm walking over to get a calculator, you can be plugging this in. So you can use your phone if you want to, because you're at home, hopefully watching this and not in school. Don't pull it out while you're in school. And if we divide these two here, we get 4. So the value of z for this here is 4. And that's it. That's all we have to do for this here. And again, our justification for solving this, or how we solve this here, is we used the division property of equality, and we divided both sides by 1.3. And that's all we did for this here. Now let's look at this next one here. M over 5 equals -4. Now to get m by itself, because there's a 5 underneath it, it's being divided by 5. What we're going to do is we're going to use the multiplication property of equality. We're doing the opposite of division. I didn't say this earlier, I really should have, but when we have something being divided like this here, m over 5, to undo that multiplication, to undo this division here, we use multiplication. And if we have multiplication, we undo it or get rid of it by using division. We use its opposite, its inverse. So what we're going to do is we're going to multiply both sides by 5. Because when we multiply both sides by 5, this is going to simplify down. Now, once we get used to this here, I'm going to just cross these out, because really we could do this here and get m. But for now, what I'm going to say is we multiply by the top. The 5 and m multiply. So we get 5m over 5 is equal to, well, -4 times 5 is -20. Well, here, 5 over 5 simplifies, leaving me with m is equal to -20. And that's all we have to do here. Now our justification is we use the multiplication property of equality, and we multiply both sides by 5 to get the value of m, to get m by itself. And that's all we had to do for this here. So we're looking at another one of these here. Solve each equation, justify each step, and check your answer. So here, 3p is equal to -2/3. So for this here, to get our answer by itself, what we're going to do is we're going to divide both sides by 3. We're dividing both sides by 3. Well, 3 over 3 simplifies, leaving us with p is equal to -2/3 divided by 3. Now at this point here, you can plug this into a calculator and we can get our answer. Now if we were to work this out by hand, what are we really saying? -2/3 is being divided by 3. Well, we've not really done or learned too much about how to divide by fractions, dividing fractions. So what we're going to do instead is we're going to take 2/3 is going to stay the same, but we change it from division to multiplication and we flip the second one. So it becomes 1 over 3, because really this is 3 over 1. Now we can multiply them together. -2 times 1 is -2. 3 times 3 is 9. So our answer is -2/9. Now this one we had to do a few more steps to simplify that. -2/3 divided by 3. Or you could have plugged that into the calculator and gotten -2/9. Either way, we will get the same answer. Now our justification for solving this is we used our division property of equality and we divided both sides by 3 to get our answer. And that's all we had to do for this here. Okay, so we're looking at this one here. So we have the equation 2.5r equals 75. So what we want to do is we want to get r by itself. So what is with r? Correct, it's the 2.5. Now what we're going to do to get 2.5 away, or to get r by itself, is we're going to use our division property of equality. Now the reason I know to use that is because the 2.5 and r here are being multiplied together. And the opposite of multiplication is division. So what we're going to do is we're going to divide both sides by 2.5. Because when we divide both sides by 2.5, well, 2.5 divided by 2.5 simplifies to 1, giving me r by itself. And now at this point here, we can do 75 divided by 2.5. And we will get that this is 30. So whenever you plug it into a calculator, you'll get that the value of r is 30. Now our justification for this here is that we used our division property of equality and we divided both sides by 2.5 and we got our answer here. So at this point here, you can pause it and try these on your own and see if you get the answer, because I'm going to work them out here too. So pause it, give them a shot, and then we'll work them together. Now the first one here, we have y divided by 3 is equal to negative 6. Y divided by 3 is equal to negative 6. So what we can do here is we can multiply, because again, the opposite of division is multiplication. We're going to multiply both sides by 3. Now I'm going to move all of this over just a little bit so that we have a little bit more room. I have a little bit more room. Because what I'm going to do is I'm going to multiply both sides by 3. Now when we multiply both sides by 3 here, these here, this 3 will simplify out with this 3 here, leaving me with just y is equal to, well, negative 6 times 3 is negative 18. And that's our answer. Now our justification is that we used our multiplication property of equality to get y by itself, and we multiplied both sides by 3, and we got our answer here. And that's it. Now let's look at the next one. Let's look at number 5. So we have 9 pi equals pi times x. Now what we want to do is we want to get x by itself. Now we see that pi and x here are being multiplied together. So to undo multiplication, its opposite, its inverse, is division. So what we'll do is we'll divide both sides by pi. And when we divide both sides by pi, well, pi divided by pi cancels out, leaving me with just x. Well, hey, look at that here. This pi and this pi cancel out, leaving me with 9. So our answer here is x is equal to 9. We used our division property of equality, and we got our answer. Now looking at the last one here, 5w equals 1.4. Now what we want to do is we want to get the value of w by itself. So we're going to use our division property of equality and divide both sides by 0.05. 0.05 and 0.05 will cancel, leaving me with w is equal to, well, now we have to do 1.4 divided by 0.05. And when we do that division, we get that the value of w is 28. And that's our answer. And the way that we got it and our justification for getting to that answer is that we used our division property of equality and divided both sides by 0.05. And that's how we get to our answer. So, 4-step approach. So we're going to do some problem solving. We're going to solve some real world problems. So we're going to understand the problem, make a plan, solve the problem, and look back at what we did. Now, look back and check and make sure it makes sense. In the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Now, when we talk about rate, or we talk about speed, and especially distance and time, we have a certain equation we use. Rate times time is equal to distance. So however fast something or someone is going times the amount of time they spent going at that speed will give us the total distance traveled. And that's what we're going to use for this here. So our rate, well, that's what they want to know. We want to find the average speed, their rate. But they told us the time was 19.32 seconds, so we'll plug that in. So we don't know R, but we know that T is 19.32 seconds. And he went 200 meters. So what do we want to do? We want to find the value of R. So to find the value of R, what we're going to do is what? We're going to use our division property of equality, and we're going to divide both sides by 19.32 seconds. 19.32 seconds. And this was our meters. And I'll come back to that in a little bit, but I'll bring that back up here in a minute. So when we solve this here, well, 19.32 divided by 19.32 cancel out. They simplify to 1, leaving us with R is equal to. So at this point here, we're going to do 200 divided by 19.32. And when we do that, so they wanted us to round to the nearest hundredth. So that's the second decimal place. So this will be 10.351. Well, this is the nearest. The 5 is our hundredths. The 3 is our tenths. So hundredths, we're rounding to the hundredths place, the second place here. So we look at the third to see if we round up or round down. Now, because the third spot is 1, it tells us that we really round down or just drop it off. So he was running, so our answer is R, his rate is 10.35. Now, if you look to see, find his average speed to the nearest hundredth of a meter per second. Meter per second. Well, the 200, that comes back to what we were dividing, what we were using. Well, we talked about that he won the 200 meter dash. So 200 meters. And what was the 19.32? It was seconds. So what did we do here? We took meters divided by seconds. So our units is meters per second. Meters per second. Meters per second. That's how we talk about meters per second, is really the distance divided by how many seconds. So he's going 10.35 meters every second, which is pretty fast. And that's all we have to do for this one here. So let's look at the next one. Suppose Usain Bolt ran 400 meters at the same speed that he ran the 200 meters. So wait, what did he run the 200 meters at? 10.35 seconds. We just found that right here. So his rate is equal to 10.35 meters per second. That's his rate. How long would it take him to run 400 meters? Round your answer to the nearest hundredth of a second. So what was our formula again that we had? Rate times time equals distance. Well, this time they told us the rate, 10.35 meters per second. But they didn't tell us the time. However, they did tell us the distance of 400 meters. So now we want to get time by itself. So we're going to do something similar to what we just did. We're going to divide both sides by what? Exactly. 10.35. We're dividing both sides by 10.35. And when we divide both sides by 10.35, well, 10.35 and 10.35 cancel, leaving me with 10 by, not 10, t by itself. So we have t by itself here is equal to 38.64734, and it keeps going on. Now it specifically asked us to round this to the nearest hundredth, 10th hundredth, so this 4 place. So to see if we round up or down, we don't look at the 3, we look at the 7. Well, since it's a 7, it means we round up, because 5 or above, we round up. So instead of that being a 4, it is now a 5. So it'll take him approximately 38.65 seconds to run the 400 meter race. Now that's all we're going to do here for chapter 1.3. So if you have any questions, please email me and I will get back with you, or I can answer them tomorrow on Tuesday. But at this point here, go on and start your homework assignment, chapter 1.3, and it will be in big ideas. And remember, because this is a virtual day, go on and do the quiz.